Hello. So I wanted to do this video because it's quite a lot of information, I think, and I think it's the easiest way to get it across. For the last, I'd say 5 years, I've been thinking about connecting my ZX Spectrum to other stuff. And indeed, I done some research and came up with some magazines that were produced in the 1980s called ZX Projects. And in there were various electrical and electronic products that you could create, you could build yourself that would link your Spectrum to other stuff. And one of those was called a latchkey card, and I've got an example of one here. Now, the latchkey card in ZX Projects, the problem I had with that and the reason I stopped doing it when I did was because I got to issue 2 and there was a mistake in issue 1, and I suddenly realized that if I were to have connected that card to my Spectrum, it would have blown something up. And I was suddenly aware of the fact that I'm connecting stuff into these 40-year-old machines. I wanted it to work. So fast forward to about 2 months ago, there was a chap on one of the ZX Spectrum forums who had said, look, I've got this old card and I want to see how it works. Does anyone know? Anyone got any instructions? And various people helped him out, and he was able to do a video showing how the card itself would communicate to the outside world. And that got me interested again. So I started Googling and I found this card here, and it comes from a company called Tynemouth Software. Now, they didn't produce the whole card. What they did is they produced just the PCB, just the bare structure that was required. And they also produced a shopping list of components that you would need in order to build the card. And lastly, they had a blog, and in that blog, they recommended this book, or they referenced this book, I should say, How to Make Computer Model Controllers for the Commodore 64, the VIC-20, the Spectrum and the BBC. And this really got me interested because now I could see a way of combining one hobby, my ZX Spectrums, to another, which is slot car racing, something I'd recently come into and found fascinating. So from the Tynemouth software, I ordered all the parts, not from Tynemouth software, beg your pardon, I ordered the PCB from Tynemouth software, I ordered the parts from an electrical supplier shop, and I put it all together, built a 3D case for it, and then tentatively turned it on to see whether or not it would work, and nothing blew up. And then I started to check whether or not any of this actually talked to other items. Now, the way that it works, there are 2 banks. One side is output, the other side is input. Each of those 2 banks for output and each 2 for input have 16 available channels, if you wish to call them that, pins that will do something. In the case of the outputs, and in the case of my project, this timing bridge, I'm able to light these lights. Now, I've been doing some machine code programming recently, never done it before, and one of the things that interested me was the relationship between binary and bits of a byte, 8 bits in a byte, if you remember that from your school days, and how the attributes worked on the ZX Spectrum. So each of these squares, the 1, the 9, the 8, the 2, the Sinclair, etc., these are all attributes behind these attribute colors, and they define the paper color, in this case white, and the ink color or the text color, in this case black. There are 2 other features, flash and brightness. So you can have it bright or you can have it normal. This is normal. And they do that through attribute settings. So you set in binary, this one here would be flash, this one here would be bright, then you've got your ink, and then you've got your paper. I can't remember the exact way around. And if you think there are 3 items for each of these, 3, 3. If you think in binary, you have 1 for the first column, 2 for the second column, 4 for the third column, and 1, 2, and 4 amounts up to 7. And if you look on your keyboard, you'll see blue, red, magenta, green, cyan, yellow, white, 1 to 7. So that's where that numbering comes in. You also have 0, and 0, of course, is black. So these are controlled by 3 items here, 3 here, 1 does paper, 1 does ink, and then these last 2 do blue. Anyway, cut a long story short, it's exactly how we control these, but we use what's called out. So out, O, and then your special feature. I'm on channel 2 of my output, and if I do 1, remembering 1 being the first binary, if we think of these round dots here as the lights, 1, bingo, on that comes. If I want to turn on, say, the first one and the third one, that's 1 plus 4 is 5. So I could say out 3, 5, and then I've got those 2 turned on. As I said earlier, 0 is off, or 0 is black, in the attributes, but 0 is off. And you can also do out 3, 255. That's everything on. Why 255? Well, in binary, if you add 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128, you get to, you guessed it, 255. So it's a good way of you being able to control all those lights. And that's what I can now do using this card via my ZX Spectrum. I can do all of that. So then we look at the input. Now the input is slightly different. I need a slightly different program in order to show you that. But the input is via in. So we'll do 10, if in 1, now I'm on channel 1 here rather than on that I was on the second bank, which is number 3. So the two banks are number 1 and number 3 for both the input and the output. So in 1, because I'm in channel or bank number 1, if in 1 equals 1, then print in 1, and then 20 go to 10. You know, simple thing here. So now what happens when I run my car over one of the two sensors that I've got in here, and these sensors are connected to these wires. These wires run around the back and come into this box. We'll come on to this box in a minute. And then this box is then plugged into my interface card, which then plugged into my Spectrum. So that goes over there. Oh, help if I run it. That goes over there. And you can see we print out all the ones. So that's down to the fact that the light sensor is now triggering information and sending it over to here. Now in this book, this tells you how to build this box. And part of this box is this chip here. And this chip is called a timer chip. And if we read in there, what that does is, because this information, this trigger is so quick, what this does is it slows it down. It grabs it, and rather than switching it off straight away, it holds it up, which is why you see so many ones printed. So of course we get around that by either holding on to that information and not printing it multiple times, or using some other programmatic method to get rid of that. So in order to run a race, what I've done is I've created a ROM. First of all, this is a ROM that I've created with a race package on there. I won't run this at the moment. What I'll do is I'll list the information. So number 1, clear screen. Number 5, let x equal 0, just a variable. 10, out 3, 0. Turn off all the lights, okay? Bunch of input variables, but then at this point, out 3, 1. Number 1 is obviously turn on number 1 light. Out 3, 3, 1 plus 2 is 3, turn on the 2 lights. Out 3, 7, 1 plus 2 plus 4, turn on all 3 lights, etc, etc. So that turns on all those lights. Out 0 we've seen already, 3, 0, that turns them all off. That's my indication to go. I then collect a timestamp, which is peeking into a couple of memory areas. And then as we, or rather as player 1 goes across that sensor, which is here, we're going to edit this line in a second, by the way. We go to we go to print the lap. We print the lap number, x plus 1, and the time, which is effectively looking at this time again and subtracting it from the time that we'd captured earlier. So we're looking at how long it took for the car to cycle around the track in order to give us that. And then we come down here and making sure that we only do it once, and then we come back to looking at how many laps we've done before declaring that the race itself is over. So I said we need to edit line 240. The reason being is I hadn't factored in that there are two sensors in here when I wrote this program initially and burnt it to this ROM, and I couldn't be bothered to reburn the ROM, and effectively it was coming up with not just the number 1 but the number 2 as well, and in certain circumstances when you go across both at the same time, the number 3. So all I'm going to do here is just make sure that it only gets triggered when we have a number 1 in the mix. So we configure what type of race. A solo race, a kind of, you know, you're just sitting there on your own doing lap times, seeing if you can beat your best lap time. I haven't configured it to have more than one person racing. Minimum lap time, this isn't actually configured at the moment. The idea of that is that when the lights go out and we start, the first thing we do is we run over this sensor, and of course at that point we trigger a lap count, but we don't want to do that. So we put a minimum time, say 3 seconds, and that will mean that when we start, we don't go across that and trigger a lap straight away. Number of laps, that is actually configured already, and then press 1 to start the race. Get ready, watch the lights, bang. So now the lights tick through, and then eventually they will all gumph and go out, and we start racing. Okay, so then we go across and we do a lap. And then as we come across the sensor, we trigger it, and you can see here, lap 1, 3.8 seconds. Boom, lap 2, 4.04, lap 3, 218, lap 4, 172, and then lap 5, 1.82. And I'll race over. So that's the light sensors connected into this box here that we used our computer model controllers to build, talking to this card here, which Timer Software produced the PCB and the list of components that you need to build it yourself, and then you go off and build it. And then of course talking to the program that you then write on your ZX Spectrum. All in all, I think it's extremely impressive. I have to say, you know, this book is what, I don't even know when it was published. I would say that at £2.95, this is probably from the 80s. And the components that I used in there, which are all in here, are all available today, so very easy to get hold of. Amazing that the 40-year-old stuff still works. And then of course, you know, we just connected into the system to give us our lap timing. So without further ado, what we're going to do is we're going to go to the track and we're going to see how accurate this timing is. We've got a known timing solution that we're going to use and compare it to our ZX Spectrum timing solution. Normally, of course, what we then do is we'll then tweak it, or we'll then look at what it is that we're doing and how we're doing it and make changes to that. I did think that you probably should write this in machine code due to the speed that's necessary to process the information, because I'm sure you could lose a couple of thousandths of a second through to the actual program code itself having to run. And so if you can make that as fast as possible, obviously you're going to get a more accurate timing system. But anyway, hope you enjoyed that. And yeah, if you're willing to hang around, we'll change camera views and go look at what the track looks like. Thanks very much. Okay, hello, my name's Paul, and yeah, so we're going to do 5 laps. Programmed the Spectrum already. I've got a lap counter here that will shout out laps as they go around, and then we can compare the lap times that we saw on the lap time that I use quite regularly versus the Spectrum. So we will press start on the lap timer, start on the Spectrum. You may not see the lights, 1 light, 2 lights, 3 lights, 4 lights, 5 lights all on, and they all go off now. 0.00. So that's the phone shouting out, not the Spectrum, and the current speech right up here. 7.40. Okay, not looking to do any lap records, just literally get the car around, get some laps counted, and we can see how accurate or not the Spectrum is 7.27 to the phone that you can hear shouting out the laps. 7.40. Alright, so 7 seconds, 7.5, 7.2, 6.8. 7.10. Okay, so move the car back round. Lovely. So on the phone we had lap 1 of 7.4, and on the Spectrum we had an 8.4, so that was very, very off. Lap 2 is 7.37. On the Spectrum we had a 7.06, lap 3 7.27, Spectrum is 7.28, getting better. Lap 4 was 7.40, lap 4 here is 7.6, and then the last lap is 7.1, and indeed on the Spectrum we got a 7.1 as well. So yeah, not bad at all. And what I'll do is I will add that information to the video so that you can compare the two. Now, of course, I will need to tweak it, figure out the timing a little bit better, work out why it's not so accurate. But overall, what a great fun little project. I hope you enjoyed watching the video, and yeah, take care. Bye-bye.